Okay, I got that fixed. I think we can go ahead. It's 8 thousandths of a second, like 0.008 seconds. That's what I put on there. I had forgotten all about that. I could I guess I could have worked it backwards because I knew what the because I knew what the answer for the force was that was put on there. But let's just go ahead and I want to show you. Welcome to my world here a little bit. Let me show you the test options. So when I click on there, so you can see what I go through when I put it. I've added the new test options. So here's and then we'll get back into the thing. So here's what we've got. Pre-lab 4, open in new, yes. Make the link available, yes. As soon as I could add a new announcement for this test, sure. I'll put that on there, and then get 3 attempts. Get your highest grade. I'm not going to afford it. There's no timer. It's going to display until April 14th. That's a long ass, I mean, that's a long time. Let's make this 11. There it is. 11:59 p.m. So that's why I like to go through it with you all. So then you turn into pumpkins. Now, if something comes up or something like that, this is where I add a user to the group. See, if I add a user to the group, then this comes up, and then here's all you guys over here, and I can just add you if you need to go in. That's what I've done for. It hasn't been, y'all haven't abused it. It hasn't been that many. Here's the due date, 3/24 for the pre-lab. It's a week from Friday. From what I'm talking to you Thursday the 16th. Tomorrow St. Patty's Day. Friday St. Patty's Day. Man, nothing like having amateur night on a Friday. Anyway, and then submitted. Boom. And so that's what it looks like. And I'll submit. There we go. Now let's go look, and then come on now, cooperate. Oh, there it goes. It's spinning. So that's what I do. That's part of my, I don't like keeping secrets from y'all. And so here we go. Let's go to pre-lab 4. Let's open it. Now it's got all the stuff in there that talks to you. Let's begin. So we're all the way down here to question 14, aren't we? Yes, now the time is equal to 0.008 seconds. That's how long the foot's in contact. So you've got, so let me show you what I've got here. So on the ladybug, question 14, I went, panicked a little bit. So you've got V final minus V initial. Well, the initial time was 0 divided by 0.008 is what you're doing. So this number up here divided by this should give you the acceleration. And then in problem 15, they want the force. Well, they give you the mass of the ball times the answer to the 14, the acceleration. So then you're on your way. All right. And then they do talk about, and they talked about impulse in those films. So you need to watch the movies so that you understand some of the questions on this assignment. Okay. I'm going to note to self, watch the movies, because I've put, there's information in those movies for you to do better. All right. Tablecloth trick. We did the spaceship thing. So there you go. So we did that one in the actual thing. Did I do this thing twice? No, I didn't. Okay. Here we go. We're going to conserve momentum, dog. All right, let's say 100 kilogram halfback is running 75 meters to the east. This is going to look a lot like that one. This is what we're doing here. Okay. At least I think that's what we're doing here. Let's go see, because that one's kind of hairy. East. Oh, they're running east and west, so it's not like this one. It's more like this one. Yeah, that one would it's more like this stuff. Okay, probably look like this. Except this time this guy's moving. All right. So for problem 20 here, I kind of want to get through this. You all probably want me to get through this. So problem 20, halfback is running to the east. He's going this way. 100 times 7.5. The linebacker 115 times to the west, negative 5. Looky what I'm talking about here. So on problem 20, 100 kilograms, 7.5 meters per second. Positive. 115 kilograms, 5 meters per second. Negative. Okay? So what's the linebacker's momentum? Remember, momentum is P times V. So the linebacker's momentum, and I'm just going to tell you his, for the linebacker momentum is 115 times negative 5. All right? Then you can do it for the next guy. Then their total momentum is you add the two together. They stick together in an inelastic collision. What is the speed of the two football players now? Okay. Well, you take that total momentum, their momentum before, and divide it by their two masses together. So what do we mean on 23? So let's take a look at problem 23. So the momentum before, you figured out, because you had the momentum of the halfback was 100 times positive 7.5. So the momentum before was equal to the momentum of the linebacker plus the momentum of the halfback. All right. Oh, I got the door open. People don't need to hear me do this. This is between us. All right. And then the momentum after is equal to the momentum before. All right. So we've got this number. Put that number right here. And then to find out the velocity that it's going, take that number of the momentum after, or you can even take the momentum before, because these two are equal to each other, and divide it by 100 plus 115. And you got how fast they're going. And if it's a negative number, they'll be going to the east. If it's a positive number, anyway, you'll get their total momentum. All right? Kinetic energy. What's the kinetic energy of the halfback? You remember how to calculate kinetic energy. We did that before. So I want you to, so the kinetic energy, just a reminder, is equal to 1/2 mv squared. Okay, so this is for 24. What else we got? 25. Add them together. Now, on 27, so 25 and 26 should be okay. Now, on 27, inelastic collision, is the kinetic energy conserved? I don't think so. So let's take a look at problem 27 real fast, then we'll be done. So 27 says this. You got to take the kinetic energy again, is 1/2 mv squared, but this time it's their combined mass. You found their final speed in 23, in problem 23. Okay, you found v. Okay, so it'd be 1/2 times 100 plus 115 times that v squared, and that'll give you the answer to 27, and you can compare that to the total kinetic energy before. I don't think they're going to be the same. Just saying. All right, out here.